good day, geometry. We are covering CO6, which has some definitions, some new words for us. The objective is to find angle measures by setting up an equation to solve. So those of you that miss algebra, well, we get a little bit of algebra today. Okay. And the first definition that we have is angle bisector. Think of that word bisector.
Two.
Bi means two. Sector or sect means section. So what do you think an angle bisector does? Not only two sections, but more specifically, two angles, two sections. What about those sections? This isn't part of the word, but just
Angles inside of two sections.
congruent. Okay, so an angle bisector is a segment, ray, or line. Recall my SRL means segment, ray, line. Coming from the vertex of an angle and divides the angle into two congruent sections. A segment, ray, or line coming from the vertex of an angle and divides the angle into two congruent sections. What an angle bisector does. So what that would look like if you have an angle like this, and it comes out like this, okay? If that were an angle bisector, I'll do it in red so it kind of stands out a little bit. If this were an angle bisector, then it would divide the angle into two congruent parts. And those arcs that I just used there are how we label angles congruent. Okay, with those little arcs there. But an angle bisector divides the angle into two congruent sections. Damien, what do you need help with? Okay.
I figured it out. It means divide.
Good job. Linear pair. Linear pair. Look at the word linear. We talked about that last year. Line. Pair is like two. So a linear pair is two angles that make a line. Okay, and I guess I've got more space, so I must write more stuff here. We'll say their measures sum to 180 degrees because that is the degree measure of a line. So a linear pair, two angles that make a line, and their measures will sum to 180 degrees. Okay, an example such as that, if we've got a line like this, and we've got an angle coming out, okay? We've got two angles there, right? One is obtuse, the one on the left. The other one is acute, the one on the right. If we're told that this angle is 140 degrees, we now know what the other angle is. Because knowing that these two make a line, and we know it's a line because it's got the arrows there, right? Knowing they make a line, knowing it's a linear pair, it sums to 180. What does the other angle have to be? 40. There you go. Linear pair is something we are going to use a lot. Okay, that's going to be a big one. Another one we'll use a lot, vertical angles. Anyone know what vertical angles are? Kylie. In this case, the word vertical means opposite. I mean, it's not the word vertical like we're used to, vertical lines straight up and down. But here it means opposite. And vertical angles are angles that are opposite each other at a vertex. Okay, angles that are opposite each other at a vertex. And the relationship of vertical angles, I said geometry is all about relationships. Vertical angles are
Vertical. Oppositely vertical.
You're closest because you said it starts with the same letter.
Oppositely vertical.
Congruent. Vertical angles are congruent. Vertical angles are congruent. Okay. An example of vertical angles if you have two segments, rays, or lines that intersect, there are four angles that are automatically created, right? Because at that intersection point, you have four angles coming out. Vertical angles would be angles that are opposite each other at a vertex. So this angle and that angle are congruent. They are vertical angles. And there's a second pair of vertical angles as well. And we'd have to mark each of these with two arcs because they're congruent to each other, but not congruent to the single arced angles. So to show that, we would use two arcs versus one. But that's an example of vertical angles. They're opposite each other, and they are congruent. If I had to pick the top 3 theorems or relationships you'll use during the year, this is one of the top 3. So this is one you definitely want to commit to memory. There we go. Okay. Next, the angle addition postulate. Similar to the segment addition postulate, the angle addition postulate says that the parts of an angle will sum to equal the whole angle. Okay, the parts of an angle will sum to equal the whole angle. Similar to, like what we talked about here. We knew this was 40 because the angle addition postulate says if we know parts of the angle, we know the whole angle has to be 180. The other part, the angle we didn't know initially or weren't given, has to be 40 degrees. All right. Questions? Yeah.
Well, that wasn't a question.
What was it? Oh. Jack. Well, the last time I assigned you 10 questions, there was an outcry, practically a riot. I had to hire security to walk out to my car. So less than 10, but I'm going to try like 8. See how that floats over. See, eventually, if you complain about everything, then I'm just going to say, well, they're going to complain about everything. It doesn't matter if I give them 8 questions or 50 questions, they'll still complain. So eventually, you've got to work with me and like come up with a sweet spot. You know, 5.
I think 6 is a sweet spot. No,
5.5.
We had 4 yesterday.
Good. True. Yeah. Okay. Well, we shall see how much we can get through in the next 22 minutes, which we're on a great pace right now. You folks are being really, really good. So far, so good. This is where we go downhill. Once I ask for any questions, I should never do it again. Christopher.
Just saying, you gave us 4 questions yesterday and we didn't complain.
No, you did not. It's because you got to play with tools.
Toys.
Some were playing with toys. Most are playing with tools. Damien.
Why do you always write in green?
I tend to use green and red for the spirit of Christmas. And red seems to be like a generally negative color. You know, like whenever you see red, you think either danger or stop when you start to drive. Green is like, let's go. Let's do this. Let's keep moving. So that's red. Yeah, blue is like ultra standout. Like, you know, black just kind of blends in too much because all the printings. I want to separate our notes from the given. That's why I don't use black. I don't know. Green just seems most appropriate. Aiden.
You said that when you see green, it means let's go. But that's,
Let's go.
But when you see yellow when you're running, that's what means let's go.
Well, that means let's go faster. That's what that means. Let's go faster.
Then you should write in yellow.
I don't have yellow. I've got.
On the top, you can change.
I don't know how to do that.
You just click it and then click yellow.
No, that's for my print though, not for my pen, right? Wait, what? What do I do?
Yeah, do that.
Oh, this?
Yellow.
Yeah, no, right. Or you can do like a nice purple.
No, you can just write.
Oh.
Put purple.
I love
Yeah, do
I love
purple.
Yeah.
Yes.
Not purple and yellow.
This is a game changer right here. This is a game changer. So you want me to do
Do purple.
purple?
Yeah.
Okay. Purple it is.
Just white.
White. Whoever said white? Who said white? Is that you? That was good. Okay. And then we also talked about with segments. We talked about the difference between a equal sign versus a congruent. When we're talking about just angles, two objects, two things that are the same, we use the congruency symbol. When we're talking about their measures, this angle is a measure of 40, which is equal to this angle's measure. Okay, then we're actually assigning a value to it, and that's when we would use equal. So when we say vertical angles are congruent, we're not talking about a specific measure, therefore they're just things. But if we say this, angle A is equal to angle B, we're talking about their measures. Notice the lowercase m, that means measure of, versus just the angle itself, just naming it, then we use the congruency symbol. We'll come back to that later on, but that's how it's used there. Okay, I promised you some algebra, so let's do some algebra. It says, oh, now it's back to green again. I got to do this every time. I don't like this. But now it looks like that. Oh, well, okay. It says, find the requested angle measure. Check your answer by verifying the relationships work. Okay, right above that, it says, it's all about relationships. Plug in the value of x and verify that everything fits together. It's like a puzzle. If a piece of the puzzle doesn't fit, it's not in the right place. So what do we know about the diagram here? What's the relationship of those angles that will allow us to set up an equation that we can go ahead and solve? Lisa. And what do we know about vertical angles? In fact, exactly the opposite. Okay, after a rousing mathematical discussion, we were talking about the relationships of vertical angles, and actually, Lisa.
Yeah, I know I was wrong.
Yes.
So they are opposite from each other, and then they
are congruent. So, knowing that these two angles are congruent, what equation can we set up? What equation can we set up that's going to allow us to solve for the variable? Knowing they are congruent, what equation can we set up to solve for the variable, Jack?
Okay, so here's my method. You put them all, so this might not be what you're asking me, but so what you do is you combine all the x terms, and then you combine all the angles, and then you combine those together, and it equals 180 degrees.
Damien?
You factor out.
How do you know it equals 180 degrees?
Because wait, I'm talking about the second one.
Oh, we're on the first one.
Oh, then I'm off.
I'll come back to you for the second one though, because you're on the right track. Bryn.
You do
Folks.
4x minus 14 equals 2x plus 7.
Yes, knowing these angles are congruent, that means their measures are equal, they are the same. So we can set them equal to each other, and it all goes back to knowing what vertical angles mean, right? You can memorize the terms. I can say vertical angles. Oh, I've heard of that before. They're opposite angles. But what does it mean? Oh, it means they're congruent. Oh, okay. What does that mean? Well, it means that their measures are the same. And if the measures are the same, you can set those two expressions together in an equation to solve. So here's where the algebra comes back into play here. We got variables on both sides. You can move this 2x over to the left by subtracting it. And we had 2x minus 14 equals 7. 2x equals 21. And x would equal 10.5. Okay. Now, when we talk about, all these puzzle pieces fitting together, if x is 10.5, 4 times 10.5 is 42, minus 14 makes this 28 degrees. Right? 2 times 10.5 is 21, plus 7 makes this 28 degrees. That's how we know that we're right, because it checks out. Okay, Alex. Yes, that's how you would check. Yep.
Otherwise, the answer is X.
Well, actually, to be fair, it does say find the requested angle measure. So if you left it at 10.5, it would not be correct because 10.5 isn't the angle measure. You should go back and plug this in there. Okay. I also ask you for CBE, which is this angle here. What's the measure of angle CBE, Aiden?
152
And,
because you subtract 28 from 180.
Good. You know this is 152 because what do these two angles make here? A linear pair, right? These two angles make a linear pair. You know one of them's 28, the other one's got to be 152 because what's a linear pair? Two angles that sum to be 180 degrees. Okay? That's geometry. Yes, Lisa. You could measure on a protractor. The danger of that is that it might not be drawn to scale. And also, yesterday, when we did use a protractor, all of us, to measure stuff, some people lost theirs because they couldn't handle them, right? Some people got 31 degrees, some got 28, some got 30, some got 33. The accuracy was a little bit off. You can't lose accuracy when you solve for a variable. You'll solve this to be 28 every single time. So that's why we would prefer an equation versus a protractor. It's tough to play with an equation as a toy. Okay. Jack, walk us through the next one. You were all over this one.
So you want to combine you want to do 5x plus 4. Well, that pair plus x minus 2 plus x plus 7 will get, and that equals 180 degrees.
Now, do those three angles make a linear pair? No, because there are three angles and not two. However, how do you know they add to be 180? Because it's a straight line. Okay. Yep. So 5x plus 4 plus x minus 2 plus 3x plus 7 equals 180. Okay? The three angles added together, we know make 180, not because they're a linear pair, but because they do make a straight line. So as Jack said, we're going to combine all of our x's. We have 5, 1, and 3. That's a total of 9. And then combine all of our constants. 4, -2, and 7 is 9. And that equals 180.
How do you get X plus 9?
I got 9x plus 9. I got the 9x from combining all my x terms, 5x, 1x, and 3x, and then my constants.
But it's going to end up being
Yes, so then when you move the 9 over and then divide by 9, you get 19. Okay? However, the question you are being asked to solve for are these angle measures here. So if x is 19, what's the measure of angle POS here? 99. 5 times 19 plus 4. By plugging 19 in for x. What's the measure of SOR? 17. 19 minus 2. And what's the measure of ROQ? Ellen? 64. 3 times 19 plus 7. Okay? And you can check yourself by do these three numbers add to be 180? Yes, they do. So you're right. So then when it says angle POR is this angle here. What's the measure of angle POR, Aiden? 116. Because you're adding the two of them together. Measure of angle ROQ, this one here, we already have that one, 64. and 116 and 64 do it out to be 180, which they should, because that's all three angles together. Okay. Questions? How are you feeling with this? Pretty good? Okay. Your homework for tomorrow.
6 questions.
Oh, we'll see. We'll see. 5.5 is what I'm shooting for.
Honestly, though, I will be okay with mine.
No word problem.
No word problem.
I will be happy.
No word
with it. Me too.
On page 29, folks, you are to do 26. There's one. Hold on now. 34, 36, 38. There's 4. Hold on.
1.5 more. And now we stop. That's a good number.
40
Are you serious right now, bro?
and 42.
That's 6.
That's 6.
That's 6. Why do you do all even?
I tried for 5.5. I couldn't get it. 6.
Of course you don't know why numbers. Why are only odds in the back of the book? Why even? You should have given us.
Why evens? I don't know. I'm feeling rather even today.
No, why are odds in the back?
I'm not an odd guy.
I would disagree.
6 questions for tomorrow. That's how you math.